Hello everybody, and welcome to your linear algebra review on the inverse of a 3x3 matrix. My name is Jason, and I work for the ASU Tutoring Centers. Now, if you didn't watch the previous video on the inverse of a 2x2 matrix, I highly recommend checking that one out. It'll give you a lot of context on how exactly we find inverses. The general procedure is you take your matrix, so let's say you have a matrix A. You take your matrix A, you augment it with the identity matrix, and then you reduced row echelon form that. Now, what you should end up with is you should get the identity on the left-hand side. So if you don't get the identity on the left-hand side, then you know that your matrix A was not invertible, okay? So must be identity here for your original matrix A to be invertible, okay? So if you don't get the identity, then your matrix is not invertible, which means there does not exist an inverse for your matrix. But if you do get the identity, then your matrix is invertible. So there does exist an inverse matrix. So you should get the identity on the left-hand side, and on the right-hand side, you'll actually get what the inverse is. You'll actually get your inverse matrix on that right-hand side. Okay, so this is the general procedure, works for all square matrices, no matter how many dimensions they are. Just toss it into a matrix with the identity, reduce row echelon form that. If you get the identity on the left-hand side, you know your matrix is invertible, and in particular, the inverse is whatever's on the right-hand side. So let's see that in action right here. So for part A, I'm trying to see if this matrix B is invertible. So what I would do is I would take my matrix B, 2, 3, 3, -1, -1, 0, 1, 2, 1. I would augment with the 3x3 identity matrix, and then I would reduce row echelon form that. I'm not going to do the reduced row echelon form operations just because we have a lot of videos of that already. So if you want to go over reduced row echelon form, check those videos out. This is more just talking about finding an inverse if one exists. So if I were to do the reduced row echelon form operations, I would end up getting this matrix on the left and this matrix on the right. And 1/2, 1/2, -1/2. So what's over here on the left-hand side now is the identity. So that's telling me that B is invertible. And in particular, this is what the inverse is. So my inverse matrix is, and I'll just rewrite it, 1/2, -3/2, -3/2, -1/2, 1/2, 3/2, 1/2, 1/2, -1/2. So that is what my inverse matrix is. And if you wanted to, you could go ahead and verify. If you took the matrix B and you multiplied it by this inverse matrix, you'll get the identity. And if you do it the other way around as well, if you take B inverse and multiply by B, you'd also get the identity. So you can verify that yes, in fact, this matrix here is the inverse by checking it through this matrix multiplication. Cool. So first one's done. First one, matrix is invertible and we found the inverse. For the second one, we do the same process, right? So we go 2, 1, 2, 1, 0, 1, 4, 1, 4, augmented with the identity. And we would reduce row echelon form that. And when we put this guy in reduced row echelon form, what we get is 1, 0, 1, 0, 1, 0, 0, 0, 0, augmented with 0, 1, 0, 1, -2, 0, and -1, -2, 1. So we have an issue, right? This is not the identity. So even though it's in reduced row echelon form, it's not the identity. So that's telling us that C is not invertible, right? Because we did not get the identity there. Cool. Cool, cool, cool. All right, so thank you for watching. As I mentioned at the beginning, I work for the ASU Tutoring Centers. So if you wanna find out more about the free resources we have available at all 4 campuses and online, go ahead and check out tutoring.asu.edu. If you want more information like this in video form that goes over specific concepts from your class, or maybe you want to see what upcoming review sessions we have, go ahead and check out this link below. Thank you again for watching, and have a fantastic day.